Hello, my lovely humans. So, integration, calculus, solving problems that relate to a changing world, all these things. We can be given anything in these questions, and the key is it's always going to be something where the acceleration or the velocity is dependent on its position or its velocity or where it is. It is something that is continually changing. It's not the uniform accelerated motion from our Owen, Kevin, John questions or the trains. It is something moving through air or something moving through water or just population change or something. So there's lots of different ways it can go. But this one is a ball of mass m is projected with initial velocity 15 vertically downwards into a tank of water. So what happens when you throw something downwards into water? It stops moving down and then floats back up, usually. So the water must be causing it to slow down, and that's what this question is about how we figure out how to understand this using our differentiation skills and techniques. So, draw a diagram. Okay, the ball travels through water with upward buoyancy force that is 4 times the magnitude of the weight of the ball, and a drag force of mv squared n. Yeah, that English there is just annoying, but it's okay. It's just lots of words for something that's easier than that. Anyway, so we have our ball. And the forces have nothing to do with the velocity. Okay, one that has something to do with the buoyancy force is the weight, and there's a drag force to do with the velocity, but the speed it's going at doesn't change what the arrows are. Okay, which is what's key, is that the force is mass by acceleration, and that isn't dependent on v necessarily. So we have down the force of gravity down, so it's mg is pulling the ball downwards. The buoyancy force is 4 times the weight, so 4 mg, and the drag force, now which way is the drag force going? If the ball is moving 15 down, that might be useful for you to do, the drag force has to be opposite, doesn't it? Yeah, that drag force has to be up. And the drag force is mv squared. And that's your diagram. You don't need this 15 thing. Do it if it's helpful, but no problem if you leave it out. So that's the forces acting on the ball. Now, the reason we do that, it's them wanting to give you some nice marks to get you started so that you have something to work with when you're trying to make the differential equation. So that's our part 1, draw your diagram. We have our weight down due to gravity. The buoyancy is 4 times the weight, and that's upwards. And then we have the drag force of mv squared, which has to be against the direction of motion. So it has to be pointing upwards because we know the ball is being projected downwards. Okay, cool. Oh, show is very nice. Show means we know we get it right or wrong. So, show that while the ball is moving downwards, the rate of change of its velocity v with respect to its distance s below the surface of the water can be expressed by the differential equation that. So, okay. We got to make some kind of differential equation out of the things we have. So, but actually, v dv ds. So the acceleration is what is v dv ds. Okay. So our acceleration is v dv ds, and the diagram we've just made is the forces is mv squared. So let's see. So we're going to say that it's, let's see, so its acceleration, the force it's experiencing, it's slowing down, so the force is going to be that direction, I think. So the acceleration, the overall thing is going to be upwards. So it's going to be a negative, which is what we want actually. Yeah, cool. Okay, so I'm second guessing myself here. So the acceleration that we see is, let's pretend that didn't happen. Okay, so let's look at this again. So the acceleration. So we have decided that downwards is positive. So the mass by the acceleration, ma, is the force that we see particle undergo, and that is mg downwards, because we've decided downwards is our positive direction. Okay, so please erase the kind of last 30 seconds of me thinking out loud. So we know our acceleration, we've decided 15 downwards is positive, so mg is positive, and then we take away 4mg and we take away our mv squared, because our mg, our gravity, is pulling in the direction of our movement, so it's adding to our velocity, but then the 4mg and the mv squared are reducing our velocity. So F equals ma, okay. Divide everything by m, gets you A equals g minus 4g minus v squared, okay. Well, that's our minus v squared, so we got that bit done, so it looks like we're on the right track. Well, what's g minus 4g is 3g. What's 3g? 3 by 9.8. 3 by 9.8 is 29.4. Excellent. So our acceleration is minus 29.4 minus v squared. Okay. And the very first thing I said was acceleration is v dv ds. So acceleration is v dv ds minus 29.4 minus v squared. Cool. We've shown, so we got that right. Cool. Again, stop, pause, we'll go back, try and work through it yourself, knowing that the method is here. Hopefully my explanation's working for you. Please let me know if anything doesn't make sense. Okay, what's next? Solve. Okay, solve this. So the first step in solving it is separation of variables. So this would be v dv over 29.4 plus v squared equals minus ds. I just brought everything on the right over except for the negative, just because it would look, I know I can easily deal with the integral of minus ds. I don't know what to do with the minus underneath the line there. So this gives us that we have minus the integral of ds equals the integral of v dv over 29.4 plus v squared. So now, as in the previous question, or any question we do, we immediately go to our tables and hopefully find a nice easy integral for this expression, which looks like hell. But we'll go to our page, where are we? We go to our page 25, 26, and we see, what do we have? Okay, we have things that look hopeful. This one has our x squared or v squared under the line, as does this, but that has a negative, so maybe that doesn't work. None of them have x above the line. None of them have x above the line. That's annoying. Right. So none of them have x at that v above the line, so we can't use these formulas. So we have then two options. We can try our integration by parts there, which might work. I genuinely don't know, but it could. But there's a integration by substitution. So of the two options, we have integration by parts from tables, or sorry, formula in tables. And then the other thing we have is integration by substitution. And unfortunately, the method in brain, we have to just remember what to do. It's actually okay. It'll work quite nicely and neatly, I think. But let's just see what we can do. So integration by substitution involves taking something, rewriting it, seeing if that simplifies our integration process, integrating, and then putting our substitute back in for the original thing, and hopefully that'll make it easy. So what I'm going to look at is, what of this what of this thing, the v, or the v squared, or the 29.4 plus v squared, what of those, if we substituted it for something, would make it easy? Oh, actually, wait a minute, there's a formula for 1 over, isn't there? Aha. If we substitute the 29.4 plus v squared, I'll put a letter in for that, then we can integrate it and get ln, and that makes it easy. Not sure what to do with the v there, but above the line, but let's see what happens. So what we do to substitute, we say we let, and we're going to use u again, so let u equal 29.4 plus v squared. What happens there what happens there then is minus the integral of ds is going to be equal to integral of something over u, which we can definitely do. That's cool. But we need to know what the dv is. So we need to find dv and replace it with stuff to do with du. So let's write that. So if we differentiate both sides here, we get du is 0 plus 2 v dv, v dv, which is exactly what we want above the line. Excellent. This means that v dv equals a half du. And then that has solved our problem, because we now have du there. We have put the half out front because it's constant, and we can now integrate. We go minus s equals a half by ln of the modulus of u plus c. Now there's two ways of doing this here. You can figure out we can change our limits, in that we can figure out if we know something about v, what does that make u, or vice versa. But actually I never do that, because it's much easier this way. All we now need to do is take this thing here, substitute it back in, minus s equals a half ln. Now it's a modulus because it has to be positive, but 29.4 is plus v squared is always positive, so we can dispense with that, plus c. And we have used substitution to integrate. The key is trying to see what can we substitute. What can we substitute in order to, hopefully the video didn't totally crash out there. What can we substitute in order to simplify it as much as possible, as quickly as possible? So we need to find out what C is. How do we do that? What do we know? At the start, we know something from the start. We know that it's 15 meters per second downwards into the tank. So we know it starts in the water at 15. So we know when T equals 0 and S equals 0, V equals 15. So we know, now there's no T anywhere, but you never know what's going to happen. So T is 0, S is 0, V equals 15. Now hopefully that hasn't killed the computer. Just give it a second to catch up. Right, so that therefore means minus S is 0 is a half by ln of 29.4 plus 15 squared plus C. And 29.4 plus 15 squared. 15 squared is 225. Is C equals minus a half ln of 254.4 ln of that equals that divided by 2. So C equals now I suppose you can leave it like that if you wanted and calculate it at the end. Maybe it's wise to do that, so we probably don't get any extra marks, so we'll just leave it like that, because the answer you get for C is equal to 2.769, which is not nice. So not wrong, but it just doesn't look good. So we've done our integration and we have minus S equals a half ln 29.4 plus V squared minus a half ln 254.4. Maybe leaving it in the ln is useful because we've got ln's in both of those things now. Right. So again, what is the question actually asking us to do? Because I just jumped straight into it. We want to solve it to find V in terms of S. So we want V equals. So I should have written down V equals at the start so I know what I was doing. So let's rearrange this thing. Laws of logs. So if we multiply everything by 2, we'll get minus 2s. And if you take logs away from each other, we can just divide into one log from our rules on page 22. 4 plus v squared over 254.4. But we want v equals, that's not helping. Oh, if we e both sides, that cancels out the ln, so that's e to the power of minus 2s equals 29.4 plus v squared over 254.4. Which then gives us v squared equals 254.4 E minus 2S minus 29.4. And this means V is equal to the square root of all of that stuff. So I'll just be lazy. V is equal to the square root of that. That's a horrendous looking thing. I don't think you can have any understanding or intuition about that being correct. So whatever the hell you get in this question, you just put that in and that's your answer. If you feel like something's wrong, just come back to it at the very end if you have time. Absolutely not worth it. So part 4 there is just algebra. So it's the ball is at its maximum depth when V is 0. So if V is 0, that means the stuff on the right has to be equal to 0. So that actually means that 254.4 E minus 2D equals 29.4. Those things have to be equal. Then divide both sides by 254.4. 9.4 divided by 254.4 is E minus 2D is equal to 0.1155. Log both sides to get rid of the E, so log that up. Log that. So minus 2D equals minus 2.157. Divide both sides by 2. Minus 2, you get D equals 1.078. So D is equal to 1.08 meters. Correct 2 decimal places. And then, okay, there's another one. Okay, and another one. Okay. After reaching its maximum depth, the ball changes direction and begins to move upwards. Draw a diagram to show the forces acting on the ball while it is moving upwards. How is that different? Okay. So we have our ball. We have our mg down. We have, what was it, 4 times? The buoyancy was 4 times up. What's different? It's moving up, so the drag has to be in the opposite direction. So the drag force has to be downwards this time. And that's it. I think everything else is the same. Like the buoyancy of the water is independent of the direction the thing is moving. Gravity is independent of the direction the thing is moving, but the direction of drag does change. Now write down a differential equation. So write down means that there's not much maths to do or not much figuring out. So the acceleration is it v dv ds? It's moving upwards. So v dv ds is 4mg minus mg minus mv squared. So it's the up, take away the downs. Yes, because it says it's moving upwards, so the 4mg is the positive thing. So that would be, so v dv ds, remembering from the very start that 3mg, so mv dv ds, okay. So we can then, that's it, dividing across by m, remembering from the start that 3mg was 29.4, so it's 29.4 minus mv squared this time. It probably could have just done that by reading the other one and just changing the sign of the, not mv squared, just v squared. Hopefully my computer seems to be struggling with that. Hopefully this has worked and you can actually see it. If not, I have to do it all again. So now we're going to look at the marking scheme. Now this part, there was 4 parts, 1, 2, 3, 4, 8. This is 40 marks or 45 marks. 50 marks. That's okay. Crazy amount of marks being thrown at us here for this. This is cool. So if you got this, it just suddenly, 50 marks for, there's lots of lines, but there's nothing too mental, I think. So let's have a look. We got 5 marks for your diagram. They have to give you something, so usually 5. Okay. Then show, it was 5 marks for showing this thing. So 5 marks for knowing that the A is the VDVDS and that force is MA and that you can create that thing. Okay. Then you got 5 marks for that, for starting off. And we got 5 marks for the, now what the marking scheme here is telling us is that the S and the C part gets us 5 marks there. Knowing how to integrate S and to have a constant of integration, or knowing how to integrate DS and getting a constant of integration, that's 5 marks. That's very, very cheap. Then it's the integration by substitution part. That's 5. Now the reason I suppose this is that if you can't do this, you don't get the next 5 and probably the next 5. So although it's only worth 5, the rest of the question is dependent on that to get that right. So I suppose it's kind of a dishonest 5, if you will. So getting to here, so getting to here was the 5, sorry, instead of this bit, so I'll screw that up. So getting to there was 5, and then getting this here, integrating by substitution correctly got you 5 marks. Getting C got you 5 marks. And then eventually getting V here got you 5. So what are we at so far? 5, 10, 15, 20, 25, 30, 40. So we're at 40. The very last answer is only worth 5 out of that 40. So we're 35 out of 40. And you could still have got it very wrong. Right. Then it was 5 marks for this. Just substituting in. It's algebra, but you're stressed, so I guess it is difficult. Then it was 5 marks for this diagram, knowing how to work the diagram in the new situation, and then it was 5 marks for this. So all in all, there's some very cheap marks going if you can get started. The key is if you go here, you write it down, you get your 5 marks for writing down what you're being asked to do. What you need to do now is, sorry, I would just move that 5. I'm just looking at the marking scheme, moving this 5. It's not letting me move it. So seeing that can't be done via the tables or by a formula, we know, and may be integral by parts, but I don't like the idea of the division thing. Just doesn't make me happy. So the substitution is worth looking at. So can you, if you were to substitute some part of this for x or for u in this case, would that be integrable? And we went, well, we know how to integrate 1 over x, so why don't we do that and see what happens? So we integrated, we we said we're going to replace the 29.4 plus v squared with the u. And then what does that make dv have to be? And if we differentiate u, we get du equals 2v dv, which is exactly perfect because it means we can move our vdv or remove our vdv and replace it with a half du. And from there, it's a simple enough integration. Put our v value back in for u, and then get our answer. So please stop, rewind, start again, ask for help in the comments. I'm very happy to go over it all again if you guys need it. Yeah, good luck.